So we now discuss our topic for today, which is sums of squares. Madali lang tong topic na to, no? This one is an interesting one. And there are already video clips, learning video clips that you can watch. There are 7 to augment our lecture for today. So you try to watch all those video clips. So let us see, sum of squares theorems. The first one here is just an example. So when you say 30, that's equivalent or equal to 1 squared plus 2 squared plus 5 squared. We have sum of 3 squares. So 30 can be rewritten as sum of these 3 squares. And then by brute force, it will reveal that 23 cannot be expressed as a sum of these squares. So meaning to say, there is actually a reason why we cannot express 23 as a sum of 3 squares. And that's what we're going to find out. There are some quantities which cannot be expressed as sum of 3 squares, or some quantities which cannot be expressed as sum of 2 squares. But for sum of 4 squares, then that's another story. Take a look at your Fermat's theorem on the sum of 2 squares. So Fermat's theorem on the sum of 2 squares says that if you have an odd prime, so it should be an odd prime, expressible in p equals 4n plus 1 for some positive integer n, then you can actually have a sum of 2 squares. So as long as that integer n can be expressed as p equals 4n plus 1, then you can also express it as sum of 2 squares. Formally, Fermat's theorem is written as follows. For odd prime p, there exists xy, element of z, such that p is equal to x squared plus y squared, if and only if p is congruent to 1 modulo 4. Meaning to say, if p is congruent to 1 modulo 4, then you can have p equals x squared plus y squared, or if p is equal to x squared plus y squared, then it can be expressed as p congruent to 1 modulo 4, because this is an if and only if statement. Example, you have 5. 5 can be rewritten as sum of 2 squares. Why? Because 5, when you divide it by 4, the remainder is 1. Diba? So, congruent siya sa P is congruent to 1, 5 is congruent to 1 modulo 4. Similarly, 17. Divide 17 by 4, you get 4. 4 times 4, 16. Na remainder na 1. So 17 is equal to 1 squared plus 4 squared. Similarly, 41. 41 divided by 4, na remainder na 1. Diba? That is 4 times 10 plus 1. So that's why 4 squared plus 5 squared can be expressed as x squared plus y squared. Is that clear? Hello? Hi? Can you still hear me?
Yes, ma'am.
Yes, ma'am.
So, nasabtan nga ng ang 5, 17, and 41 are expressible as sum of 2 squares? Hello?
Ma'am, pwede balikan nga nung 41 kay Koan.
Ang
Ma-express
41.
siya as sum of
Okay. 41 is congruent to 1 modulo 4. Diba? Ato man ang atong ano, what is 41? 41 is, when you divide by 4, it's 10, remainder 1. Correct? So, it can be expressed as
Yes,
10 remainder 1. Kani, 17 when you divide by 4, that is equal to 4 remainder 1. 4 times 4 is 16. Similarly, ang 5. That is 5 divided by 4 is 1. Diba? 4 times 1 plus 1. So, remainder 1. 4 squared. Ito kasi yung inyong theorem. Let me go back to the theorem para ma-remember ninyo. Kanya, P is congruent to 1 modulo 4. So, when you divide by 4, the remainder is 1. So, you can express it as P equals x squared plus y squared. Clara na?
Yes, ma'am. Thank you,
Okay.
ma'am.
Or pwede na eh. Kanino, if P is equal to, kanina statement, P is equal to 4n plus 1 is the same as this. P is congruent to 1 modulo 4. So, nakakay factor of P, factor of 4 plus 1. So, it can be expressed as the sum of two squares. So, na may idea kung kanus siya ma-express as sum of two squares. If it's divisible by 4 with a remainder 1. Not divisible. It is 4 times n. So there's a factor of 4 times n plus a remainder 1. Always na siya. So meaning to say, dili siya divisible. Okay? This one, if your 7, 19, and 31 are all congruent to 3 modulo 4, and this time cannot be expressed as a sum of two squares. Kaya kinahanglan man nato kay 1 mod 4. So the value 3 mod 4 is not anymore divisible. Naman, ang remainder niya ani kay 3 man, di ba? Modulo 4. So this one cannot be expressed as a sum of two squares. How about 2? Can you express this as a sum of two squares? So aside from this, napatay, is 2 expressible as a sum of two squares? Anyone? Hello? Hello? Des? What is 2? Tawagin ko dito. Mga leader. Tandano. Give me, express 2 as a sum of two squares.
1 squared
Ma'am,
plus
no
1
ma'am.
squared, ma'am.
Correct. Very good. 1 squared plus 1 squared. So aside from P congruent to 1 modulo 4, you can also have P equals 2. Because P equals 2 is expressible as a sum of two squares as 1 squared plus 1 squared. Trivial na sing result. That's why kanina hindi binigay. Pero as a theorem, you can rewrite this. Or aside from P congruent to 1 modulo 4, then it is also a sum of two squares if we have P equals 2. So we have a lemma here. Suppose that n equals a squared plus b squared and that the prime factorization of n contains the prime factor q, where q is congruent to 3 modulo 4. Then q divides a and q divides b, and q must appear to an even power in the prime factorization of n. We have here another lemma. If you have m and n a sum of two squares, then ang product daw niya kay sum of two squares gihapon. And the proof is actually straightforward. You simply take m, which is already given as a sum of two squares, a squared plus b squared, and n is equal to c squared plus d squared. When you take the product, a squared plus b squared, and n is equal to c squared plus d squared. Pag i-multiply na sila, result mn will give you this one. You multiply this. N is equal to AC plus BD squared plus AD minus BC squared. You can actually try to work on this, and you should come up with the result, which is this one, which will be, remember, this is already a sum of, this is a square plus this is another square. Notice na minus na diha, no? Tapos diri puro plus. So I will leave to you to verify this. But this can easily be verified. Kaya algebra naman yung part. So, you have, if you have m, sum of two squares na sila given, then ang n, sum of two squares, gihapon siya. Pag i-multiply sila, ang result is also a sum of two squares. Okay? It's actually a lemma. Then we have the following. This remark says that if you have n equals x squared by y squared, which is the sum of two squares, either you have even squared, even quantity squared plus even the quantity squared, or add the quantity squared plus add the quantity squared, or even the quantity squared plus add the quantity squared. Okay? Now, if the sum n is odd, then only the last case applies. So it must be n is congruent to 1 modulo 4. Kanina, these are some low values of n na pwedeng na-express as sum of two squares. Take a look, binigay ninyo kanina 2. 2 is 1 squared plus 1 squared. 0 can still be expressed as a sum of two squares. 0 squared plus 0 squared. 1 is 0 squared plus 1 squared. But 3, because it's 3 is not congruent to 1 modulo 4. So it's not expressible as a sum of two squares. 4 is expressible as a sum of two squares. 0 squared plus 2 squared. And then 5 again, expressible. But 6 is not. 7 is not. Because 6 is not congruent to 1 modulo 4. Similarly, 7 is not congruent to 1 modulo 4 and 8. But here, 8 here is congruent to actually 0 mod 4 na. So 8 squared plus 2 squared. You can still express. 9 0 squared plus 3 squared. And down the line. 1 squared plus 3 squared. So an odd prime P is a sum of two squares of integers if and only if we have P is congruent to 1 modulo 4. So this one is a question about sum of two squares. So if it is an odd prime, it can be expressed as a sum of two squares as long as we have 1 modulo P. Remember, prime, odd prime, and P. Three square theorem. So we already done with sum of two squares. We now go to sum of three squares. It says that if you have a natural number n, it is expressible as the sum of three squares if and only if your n should not be equal to 4 to the a times the quantity 8b plus 7 for integers a and b. So formally, for n element of the natural numbers, there exists x, y, z element of your integers such that n can be expressed as the sum of three squares if and only if there is no ab element of z such that you have n equals 4 to the a times the quantity 8b plus 7. Now, this is very difficult to prove actually, and it took for full 28 years before Legendre discovered his first proof for the case k is equal to 3. So you're not going to prove this. So it was found, k is equal to 4 was found in 1770. So we go now to what values for k. Example muna tayo sa ano. Let's see this one.
Excuse me, ma'am.
Yes, yes. So this, yes, question.
Pwede balik sa slide. Pwede balik sa last slide, ma'am.
Okay, let's like this one. What's your problem here? So there exists x, y, element of z, element of, yes, what's your question?
Ma'am, sa definition, ma'am, kay n is not equal to 4 raised
Yes.
to 8.
That's why it says
Pero
there exists no a.
Okay.
Kaya there exists no ab, element of z. Ano yan? There exists no, not equal man, di ba? So that's why there exists
Okay,
no
yes,
ab, element of z such that. Nakuha na ang definition? At saka ang theorem?
Yes, ma'am.
Okay.
Yes, ma'am.
So
Nakuha na.
it says
Thank you,
here,
ma'am.
there exists no. Wala na mag-equal sa ani. Because n is not equal to. Okay? Sige. Nasabda na?
Yes, ma'am. Salamat, ma'am.
Okay, good. Let's go to the next one. Example tayo para makita mas clear siya. You have here 13, 26, and 41 cannot be expressed in this form. For some integers a, b, so because we cannot express them as 4 to the a times 8b plus b square theorem, then this one, this 13, can be expressed as a sum of three squares. So kung dili siya ma-express kaning nga form, ma-express siya as a sum of three square. Nakuha ninyo? Dili siya ma-express ani nga form, mao na nga ma-express siya as a sum of three squares. Is that clear? So kinahanglan dili siya ma-express ani nga form. 4 to the a times 8b plus 7 para ma-express siya as a sum of three squares. Okay? So 13 is equal to 0 squared plus 2 squared plus 3 squared. And 26 is equal to 1 squared plus 3 squared plus 4 squared. And 41 is 3 squared plus 4 squared plus 4 squared. Now, by brute force, kaning 15, 28, and 92 cannot be expressed as sum of these squares, kaya ma-express man siya as kaning 4a times 8b plus 7. So I will leave this to you, although na naman din ang explanation. I will leave this to you to read on. Okay? Para ma-verify ninyo. Let's go to the following. So, remarks. Let's summarize what we have learned. Positive integer can be expressed as a sum of three squares if and only if dili siya aning nga form. 4k, 8m plus 7. Ganyan nagamit natin A. You can use other letters here. Tapos 8b ang ginamit natin. So, pag ma-express siya aning nga form, dili siya ma-express as a sum of three squares. Yun yung question kasi kanina, di ba? So, iklaro lang diri that the theorem says a positive integer can be expressed as a sum of three squares if and only if dili siya ani nga form. Pero kung ingon ani siya nga form, ma-rewrite mo siya ani nga form, then you can now have sum of three squares. So kung dili siya ani nga form, nakay sum of three squares. Pag nakay sum of three squares, dapat dili siya ani nga form. Because this is an if and only if statement. Okay? Now, how about sa sum of four squares? Ang sa sum of four squares, this is very trivial. Okay? It says every positive integer is the sum of four squares. So any positive integer can now be written as the sum of four squares. So nanatay criteria for sum of two squares, sum of three squares, and this time it says that every positive integer is the sum of four squares. And we call this your Lagrange four-square theorem. Or sometimes it's called Bashet's conjecture, which says that every positive integer can be expressed as a sum of four squares. Or formally, Lagrange says that for all n element of the natural numbers, there exists a, b, c, the element of z such that ma-express ninyo as a sum of four squares. Okay, examples. 3 can be rewritten as 0 squared plus, simply have this. Ang 31, 1 squared, 1 squared plus 2 squared plus 5 squared. Ang 310, 1 squared plus 2 squared plus 4 squared plus 7 squared, 17 squared. So you can express any positive integer as a sum of four squares. But the lemma here is quite important because it says that if you have 3m is a sum of four squares, then kaning m daw is also a sum of four squares. So kung naa may 3m, niya kaning 3m sum of four squares, then m is also a sum of four squares. For example, 3m equals a squared plus b squared plus c squared plus d squared. This is actually the proof. We can take specific value for 3m. So since every square is congruent to 0 or to 1, modulo 3, there are only two possibilities. I will leave this to you to read, to go through. This is just algebraic solution as well as properties of modulo. Para ma-review po din yung modulo properties. So you end up with the following. 9m over m, 9 is equal to m. So therefore, m is the sum of four squares. Kaya if you take a look, you have there, ma-divide ang pa siya, 3a squared plus 3b squared plus 3c squared plus 3d squared over 9. And this is the formal proof. So you have that one. It's the source. Okay.